Welcome to this session on best practices for dissolving PLGA in organic solvents. If you've ever worked with PLGA in the lab, you already know this polymer can feel like a reliable partner on some days and a rebellious teenager on others. Today, I'll walk you through the practical side of PLGA dissolution, the small details, the common pitfalls, and the tricks experienced formulators quietly rely on. Think of this as a journey from everyday frustrations to clear, systematic solutions. PLGA looks deceptively simple, but once you start dissolving it, things get interesting. I still remember a moment early in my career. I spent 2 hours trying to dissolve PLGA, switching solvents, adjusting temperature, thinking I was doing something wrong. Only later did I discover the real problem wasn't the solvent at all. It was the polymer's high molecular weight and acid termination. That experience taught me something important. Before choosing a solvent or changing conditions, you need to understand your polymer. Dissolution challenges often trace back to PLGA's own characteristics. Whenever someone says their PLGA won't dissolve, I immediately ask 3 things. What's the molecular weight? What's the lactic-to-glycolic ratio? And is it acid-terminated or ester-terminated? These 3 factors change everything. High molecular weight PLGA dissolves slowly, and it loves forming those annoying midway gels. High lactic PLGA is more hydrophobic, so it dissolves more easily in organics, but also alters drug release behavior. And acid-terminated PLGA? That one loves forming hydrogen bonds, which slows dissolution and accelerates degradation. Once you know these variables, troubleshooting becomes much easier. Let's talk solvents, because not all of them treat PLGA the same way. If you want fast, almost guaranteed dissolution, DCM is the top performer. Chloroform comes close, especially with higher MW polymers. If safety or regulatory concerns matter, like in biomedical formulations, you might lean toward ethyl acetate or acetone, even though they work more slowly. And for very specific formulations, particularly those needing high boiling points, NMP or DMF come into play. So the choice isn't just about dissolving quickly, it's about choosing the solvent that fits your final application. Here's a workflow I've refined over the years. Simple, but incredibly effective. Start with your solvent at room temperature. That prevents premature precipitation. Add the polymer slowly into the solvent, not the other way round. Use gentle stirring. Think smooth vortex or magnetic stir bar. If you shake aggressively, you'll create microgels that never fully dissolve. Depending on the polymer's molecular weight, give it anywhere from 10 to 45 minutes. And always check for clumps along the walls. If you see cloudiness or pellets sticking, address it early. Following this routine alone solves nearly 80% of dissolution issues. If you've worked with PLGA long enough, you've met the infamous gel ball, that rubbery mass that forms out of nowhere and refuses to dissolve. To dodge this nightmare, add your polymer gradually. Never dump it in. Break up any lumps before adding them. For high molecular weight PLGA, pre-wetting with just a drop of solvent makes a huge difference. And always use enough solvent. Don't work at the edge of saturation. Gentle handling goes a long way. Gentle stirring in, gentle mixing throughout. It keeps PLGA from turning into that stubborn blob. One common assumption is, if it won't dissolve, just heat it. But with PLGA, this is almost always the wrong move. A tiny amount of warmth, maybe 30 to 35 degrees Celsius, can help start dissolution. But go above 40 degrees and you risk early hydrolysis, especially with acid-terminated polymers, or if there's even a trace of moisture around. So, think of heat as a last resort tool, not part of your standard procedure. Moisture is one of the biggest hidden causes behind poor PLGA dissolution. Even a few drops of water can make the polymer swell instead of dissolve. I once struggled with a batch for an entire week before discovering that someone had accidentally left the polymer bottle open. Since then, I treat moisture control like a core part of the formulation process. Keep containers closed, work with fresh, dry solvent, and in humid environments, store PLGA with desiccants. Small habits here pay off enormously later. When problems show up, and they will, here's a quick troubleshooting checklist. If your solution looks cloudy after 30 minutes, increase your solvent volume or move to something stronger like DCM or chloroform. If a gel ball forms, slow down the polymer addition or reduce your concentration. If dissolution feels painfully slow, check your molecular weight. You may simply need more time. If the polymer looks swollen but never fully dissolves, moisture is the likely culprit. Great formulators aren't the ones who avoid problems, they're the ones who diagnose them quickly. To wrap up, dissolving PLGA isn't an art based on luck. It's a science driven by understanding and good habits. Know your polymer's characteristics. Choose a solvent that matches your final application, not just what dissolves fastest. Follow a thoughtful workflow, prevent issues like gel balls or moisture exposure, and handle heat cautiously. When you approach PLGA this way, everything from nanoparticles to films becomes far more predictable. Thanks for joining me. Remember, good formulations always begin with strong fundamentals.